All right, so on 25, we are graphing we're going to give the parent function, list the transformations, and then graph. Then we're going to identify the domain range using interval notation, and we're going to give the asymptote of the function. So notice this is an exponential function. The easiest way to do the parent function and list the transformations is to list the transformations first. So what transformations do you see on 25? Reflect over x, right? The negative sign in the front, that tells you to reflect over the x-axis. All right, and what is the other transformation you see here?
Down 4.
That's right, down 4. So that's right there. If you recognize the transformations, or at least where the transformations are, notice I've highlighted the transformations, right? Whatever's left, that's your parent function. Because the parent function is your function without transformations, right? So what is my parent function here?
F of x equals 10x.
10 to the x. Yeah. 10x would just be a line. 10 to the x is an exponential. All right, so that's right. So now we've got the transformations, we've got our parent function. Now we just need to graph. So remember, when you graph, you get the points of the parent function. So we're going to have x right here. How am I going to find my y's then? The y's come from the parent function. What is the parent function? Right, 10 to the x. So your y's are going to be y equals 10 to the x. Okay, so what value should we use for x? Negative 1, 0, and 1. Right. If you had the negative 2 and 2, it would be more accurate, but it's fine to just have this. Okay, so when I plug in 0 for x, what do I get? 1. When I plug in 1 for x, what would I get? 10. So then negative 1 would be? 1/10. That's right. Okay, now I just have to apply my transformation. So the first one is reflect over x. And what would that do to my table?
Make your y.
Right, make the y's negative. So reflect over x right here. We have negative 1/10, negative 1, and negative 10. Then we have down 4. What would that do to my table? Subtract 4 from the y's. That's, oh, I read it up. Wow. Down 4. So negative 1/10 minus 4 would be negative 4 and 1/10. Negative 1 minus 4 is negative 5, and negative 10 minus 4 is negative. That's right. And so there are your points right there. So we're going to graph those. Negative 1, negative 4, and 1/10. So it's like very close to 4. 1, 2, 3, 4, like right about there. Then we have 0, negative 5. 1, 2, 3, 4, 5 right here. And 1, negative 14 is like way off over here somewhere. And so if you connect these points, it should look like something like this. This is a very bold graph right here. All right, so now let's do the asymptote. What is the asymptote here? Y equals 0, so right here. Is that the right answer? Is that where the graph's approaching? Where's the graph approaching? Right, y equals negative 4. Remember, the transformations up and down tells you where the asymptote is on the exponential. Because it was down 4, you could know right from the beginning the asymptote's going to be at y equals negative 4. You guys are saying y equals 0, right? That's the starting. That's the parent function asymptote always, y equals 0. But then, based on if it's moving up or down, that's going to move your asymptote as well. All right, so what is we're doing interval notation, right? So what is your domain here? That's right. The domain's negative infinity to positive infinity. What is the range, though? Negative infinity to negative 4. Very good. Very good. Why did I put a parentheses around negative 4? Because it doesn't actually touch negative 4. That's the asymptote. And that's going to end number 25, I think this was.